All righty, friends. How we doing? How we doing? It's good to see you guys today. All right, so we're going to go back to an oldie but a goodie a little bit. We're going to go back and talk about graphing sine and cosine, but it's honestly very similar to what we did before. We're going to be dealing really with transformations. So we'll have to review a few things as we go through, but we'll talk about it as we go. So when we're looking at graphing any sort of trig, what we're looking at essentially is how do we take the graph and shift it all over the place. So on your notes, you can kind of see, let me see if I can zoom out a little bit. Zoom out a little bit more maybe. Alrighty, so we're getting a little bit closer. There we are, that's what we want. And you can kind of see how, if I were to keep going here, the graph kind of makes this little curve. Now, since it's on a unit circle, the graph, if I were to graph it all the way, it's going to alternate back and forth between 1 and -1. There's 1 and -1. It's going to alternate back and forth, making that shape repeatedly over and over again. So right there, that's where it would be at 2 pi. But this graph, since it's on a circle doesn't change. So it would just keep repeating itself over and over again. It would keep repeating itself over and over again. There's -2 pi right there. This would be a positive 4 pi. It would just keep repeating itself over and over and over again. Well, we don't care about having this graph repeatedly go on forever, since it does go to infinity. What we care is just about what happens from 0 to 2 pi. What happens on just that first rotation. And we call that the graph's fundamental period, or its period length, because that's what happens on that normal time. So we only care about that graph from 0 to 2 pi. And that's what you see here. This is kind of what the graph looks like. It's a nice kind of curve as it goes through. We call that a sinusoid curve. So as you're kind of looking at this graph, what you end up seeing here is it has essentially, going back to what we did first semester, it has a relative max. But realize that relative max is going to not just be here, but it's going to repeat itself on every single period. It's going to have a relative min. It's going to be the bottom of a hill, the lowest point of the graph, where the graph goes from decreasing to increasing. And again, it's not just going to be there, but it's going to be on every period length. We've already talked about how sine and cosine can be odd or even, but in terms of what we're dealing with as far as graphing is concerned, it's a real easy way to tell. If it has rotational symmetry, so like a pinwheel around the origin, which is the point 0, 0, okay, that's the point 0, 0, then it will be an odd function. And we're going to get a lot more of these odds and evens here when we're looking at these. And if the graph has a relative max or a relative min for sine or cosine on the y-axis, then it would be even. For instance, you can now, as far as just the generic sine, you can kind of see right here, I have a point right here at 0, 0. If I were to spin it 180 degrees, I'd get the same graph. So sine itself is a even, or is an odd function. And again, we've talked about that. We've talked about that a little bit. So Now, the reason why I say we're going to go back to an oldie but a goodie is the graph for these isn't going to be hard. We're going to go back and deal with one of our first semester essential skills. We're going to go back and use this idea of transformations form. We're going to use our values of x and y, and then we're going to transform them. And the nice part is, if you notice, there's 5 points, that are very, very important, just as sine and cosine. So we're going to spend our time here at the beginning looking at sine, but realize when we move to cosine, it's going to be the exact same thing. All that changes is just the points we start off with. So our first point is 0.00. And so unlike transformations we had before, these ones, the starting points, they never change. They're always going to be the same. And then we have pi over 2 and 1, because sine of pi over 2 is 1. And we have pi and 0. Again, friends, this is the graph y equals sine x. That's our parent function. And then we're going to move it all over the place. Our next point is 3 pi over 2. And negative 1. And then our last point is 2 pi and 0. And we're going to take these points and we are just going to end up doing our transformation for them. So while we're starting with sine, what we're going to end up getting to is a graph that is y equals a times sine of b x minus c plus d. So it's going to be all our same transformation stuff that we did back in the very first unit of the year. And if you remember, for transformations, we always said we take the b value and we divide it into x, and then we add c. That's going to be the same thing we're going to do with our trig. Nothing's going to change. It's going to be all the same stuff. We're going to take our a value, just like we did before. We're going to multiply it by y. We're going to add d. Nothing changes. And we'll get our new points from those transformations. Now, as you go through here, you're going to talk about essentially the period length. So the period length, we'll get to that here in a second. Okay? But this is going to be what we're playing with today. We're going to take this one curve, this one sine curve, and we're going to start to move it all over the place and then be able to find some things about it. Okay? And again, we'll be able to look at its relative min and max. We'll be able to figure out its y-intercept. Remember, the y-intercept is every time the x value is 0. We'll be able to talk about the graph being odd or even. Now, if you notice the domain and range, the domain is always going to be pretty easy for these graphs, because if you notice, when we were dealing with these graphs, the graph is always going to go forever to the left and forever to the right. So the domain is always going to be all real numbers. But the range is going to be somewhere between -1 and 1, at least for the original function. As we start to move it and shift it, that'll change a little bit. So let's put this all together here. And if we put it all together, we end up getting our actual equation, which is what we just talked about. Now, I need you guys to do one thing to your notes. This period length, that should be an absolute value. So the period is always going to be 2 pi divided by b. The amplitude This should also be an absolute value. The amplitude is also the absolute value of A. So every variable on our equation tells us a little something more about the graph. If you're ever looking at a graph itself and you need to find the amplitude, you do it a little bit slightly different way since you don't have an equation. If you have to find the amplitude given the graph itself, you just take whatever the maximum value is, and you subtract the minimum value, and you divide it by 2. So if you ever are given a graph and you have to find an amplitude, it's the maximum value minus the minimum value divided by 2. It's essentially just the average. So in our case, let's go back and take a look at the just a regular sine graph. We said that the largest value is 1, that the range is from 1 to negative, or negative 1 to 1. So 1 minus negative 1 divided by 2. So 2 over 2 is 1. So y equals sine x would have an amplitude of 1. So what we're going to do is we're going to be playing with this idea of sine and cosine and just kind of graphing the functions. But it's not anything we haven't done before. All right, it was that transformations essential skill that we did first semester. We're just going to use trig now for it. So we'll go through and we'll deal with all these things here along the way. All right, so whenever we're first given a graph, we start off and we have to label our A, our B, our C, and our D. So A here is 2. B, that's 1. C is pi. And D is 0, since I don't have one. And again, this comes from the idea that y equals A times sine of B times x minus c plus d. So since we're dealing with sine, they're always going to start off having the exact same points to begin with. So we can go ahead and we can write our points in here. So I have 0, 0. I have pi over 2 and 1. I have pi and 0. And I have 3 pi over 2 and negative 1. And then we have 2 pi and 0. So we have our initial points, and I know what A, B, C, and D are. So we're going to just take them. We're going to take our 5 initial points, and we are going to move them. Now, there's a bunch of different ways to graph this. I'm choosing to graph it using transformations. A lot of people like to use something called a midline to graph. There's different ways you can do it. Some people just like to do a series of regraphs. I'm not a big fan of that one, but hey, to each their own. So remember, we're going to go x divided by b plus c, and then, which is the same. And then we're also going to go y times a plus d. So what does that mean for us here? Well, for us, our b value is 1, so that's not going to change anything. So x divided by 1. And our c value is pi, so we're going to add pi. Our a value is 2, so I'm going to go y times 2. And I didn't have a d value, so that's 0. So that's what we're going to be dealing with the entire time. So as we graph this, these will end up being the new points. So Take each point and plug it in. 0 divided by 1 is 0 plus pi. That would be pi. Pi over 2 divided by 1 is pi over 2 plus pi would be 3 pi over 2. Now you guys are going to have to add a little bit with fractions as you go through. Pi divided by 1 is pi plus pi is 2 pi. But as pre-calc kids, we should be decent at graphing by, or about adding fractions as we go through. And 3 pi. Then we got to do our denominators here. 0 times 2 is 0 plus 0 is 0. 1 times 2 is 2 plus 0 is 2. And then we have 0. We have negative 2. And we have 0. Now when I go to graph this, I always look at my x values. And I take a look at whatever my largest denominator is. So in that case, my largest denominator is 2. So I'm going to graph then by pi over 2. So I always graph by pi over whatever the largest denominator is. So when I go to graph the dumb thing, I can see that my largest value is positive 2. I can see my largest value is a negative 2. And then I'm going to graph by pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. 6 pi over 2 is equal to 3 pi. So this is 3 pi. Remember, 3 pi is the same thing as 6 pi over 2. Pi is the same thing as 2 pi over 2. So we always count by the smallest denominator, or the largest denominator. And I'm going from 2 to negative 2. So as long as I label my axis, then I can go ahead and graph all these. You have to make sure to label your axis. Right? Don't leave it up for me to figure out. If you don't label your axis, you don't get full credit. So make sure you label your axis. So I'm going to put my values on here. 5 pi over negative 2. If I do this right, I should give myself a very nice looking curve. So I'm going up and down. And again, I'm only graphing just its fundamental period, just from that would have been where the fundamental period would have gone to. So now we're going to go through and answer a whole bunch of questions. First of all, amplitude. So what is the absolute value of A? That's what amplitude is. So my A value is 2. So the absolute value of 2 is 2. I have an absolute value of 2. Vertical reflection. We're always going to be asked, does it have a vertical reflection? In other words, is A negative? Is A negative? Vertical reflection, A was positive, so that would be a no. Period is always going to be 2 pi divided by the absolute value of B. So for here, I have 2 pi divided by the absolute value of 1. So my period length is still 2 pi. My phase shift is always my C value. So since C is a positive pi, that means my phase shift, went right pi units. My vertical shift, that's always my D value. So since D is 0, I don't have a vertical shift. So since D was 0, my vertical shift is none. I didn't have one. So let's see what we've done up here so far. How many of these things do we deal with? Amplitude, we did that. Period, we did that. Phase shift, we did that. Vertical shift, did that. Domain, okay, let's go ahead and deal with domain. Let's deal with domain and range next. These are going to be the things that you have to do for every graph. Domain. Well, we said before, domain is always for the sine and cosine. It's always going to go on forever. So the domain is always all real numbers. Or if you wanted to, you could use negative infinity to positive infinity. That works too. And if you do that, though, make sure you put those in parentheses. My range, I went from -2 to all the way up to +2. So you can write it as inequality. I actually prefer that you write it with brackets and parentheses. So this one would be both brackets from -2, bracket -2 to +2 bracket. I prefer that. It's just easier to read. But whatever works for you, friends. All right, let's see here. Y-intercept. So for the Y-intercept, I don't have that yet. But remember, there's a couple ways to think of it. This graph is going to continue going the same pattern. So if I were to keep going here, if I were to keep going, one way to see it is I could just keep drawing it. And I can see that it's going to be 0, 0. But if we don't trust ourselves from drawing the pattern repeatedly, you can always just plug 0 in for x. And we know how to evaluate on the unit circle. So this would not be a big deal for us. So let me go ahead and show how just plugging 0 in for x there. Y equals 2 times sine of -pi, which is the same thing as positive pi. They're coterminal. So that's 0. So y equals 2 times 0. Y equals 0. So the y-intercept would be 0, 0. So you can either figure it out by using the graph, or you can just plug it in. Now, even odd or neither, this is where we look at our graph and say, all right, even means I'm going to have a relative min or max on the y-axis. A relative min or max on the y-axis. I don't have that. Okay, you have to go back and look at what we had before. Even relative min on the y-axis or the x-axis. I'm sorry, on the y-axis. Relative min or relative max on the y-axis. Odd means that I have 180-degree rotational symmetry, 180-degree rotational symmetry through the point 0, 0. If you notice, I do have that. If I were to rotate 180 degrees, I would have that. So this would be odd. This is an odd graph. And then we have our relative extrema, which we did relative mins and maxes back when we were looking at polynomial and rational functions. So a relative min, we said that this was the bottom of a hill. So the relative minimum, this is always going to be the bottom of the hill. So we're going to always end up with some x value and some y value for a relative min. Relative max is also going to be the same thing, but you need to remember something. These graphs go from forever. So that means I have an infinite number of relative minimums and I have an infinite number of relative maximums. So because of that, it's more than just the relative min and max. These things are going to repeat over and over and over again. It's going to repeat whatever the period is. Well, I'm not going to go and actually write all infinite number of them. I'm just going to add the period times n. And n it would be the number of rotations around the unit circle, or around the circle itself, which would be how many different ways it goes. So when I'm dealing my relative min and max, because there's an infinite number, I'm going to always add to whatever the x value is, 2 pi over b, so the period length divided by n. So our relative minimum here was this guy. He is my smallest value. So my relative min, that takes place at 5 pi over 2. And my period was 2 pi. So I'm going to add 2 pi n to it, because that tells me that it can go on and on and on forever. 2 pi over n, comma, whatever that would be -2. And this over here, my relative max, that's going to be this guy. So that's the point 3 pi over 2. And we're going to add 2 pi over into it. And that y value is 2. So there we go, friends. That's all the stuff you'd be asked to do on a sine or even a cosine graph. Cosine is just going to have different starting points, but everything's the same. So go ahead and pause the video. You can see number 2 down there. Go ahead and pause the video and give number 2 a try. Go for it. Let's see how y'all did. Let's see if I can go. There it is. Again, let me write this in there so we have it. So y equals a times sine of b x minus c plus d. All right, and I'm going to go a little bit quicker through this one here. So before I do anything, I better take my graph and make all my values pop out. So there's my a value. I have to factor out that b value. So when I factor out a 3, that's the same thing as multiplying by 1/3. So when I factor out a 3, this becomes pi over 6. That seems to be the most missed thing, is making sure to factor out your b value. So a then is going to be -1. B is 3. C is not negative pi over 2. C is going to be a negative pi over 6. And D is -2. So absolute value of A. So my amplitude is 1. Vertical reflection is A negative. A is negative. It's because it was a -1. So yep. Period is 2 pi divided by the absolute value of B. Notice, I didn't have to actually get into the graph to be able to do some of these things. So 2 pi is absolute value of B, so 2 pi divided by the absolute value of 3 would be 2 pi over 3. My phase shift, that's my C value. So since C is negative pi over 6, that means I'm going left pi over 6. D, that's my vertical shift. Since I was -2, I'm going to go down 2. And I can go ahead and add domain here to this in range. I'm pretty sure this is a sine graph. My domain is going to be all real numbers, and I'll come back and deal with the range once I figure out what I'm dealing with. Again, remember the starting points, they'll never change. They never change. So 0 and 1. I lied. 0 and 0. 0, 1 is cosine. 0, 0, pi over 2, 1. Pi 0. 3 pi over 2. and -1 and 2 pi. So these are our starting values. And we can do our transformation again. So x divided by b plus c, and y times a plus d. So in this case, I'm going to go x divided by 3 minus pi over 6. I am going to have to do some fraction stuff here. And y times -1 minus 2. So if I plug 0 in here, 0 divided by 3 is 3 minus pi over 6. That's negative pi over 6. Plug pi over 2 in. Pi over 2 divided by 3 is pi over 6. Minus pi over 6 is 0, the hero. Pi divided by 3 is pi over 3, which is the same thing as 2 pi over 6. So 2 pi over 6 minus pi over 6 is 1 pi over 6. What you end up doing here is you start to see how they're counting since they're equally distanced apart. 3 pi over 2 divided by 3 is pi over 2. And pi over 2 is 3 pi over 6, so that's 2 pi over 6. 2 pi over 6 is the same thing as pi over 3. I'll give you a hint. Looks like I'm counting by pi over 6s here, so this is probably going to be 3 pi over 6. So 2 pi over 3, that's 4 pi over 6, minus pi over 6, that's 3 pi over 6, which is pi over 2. They're always going to be equally width apart. Later on, that's something we would call in calculus, we'd say that's normed width. We take our 0 and plug it in. 0 times -1 is 0, minus 2. Plug my 1 in here. 1 times -1 is -1. Minus 2 is -3. -2. -1 times -1 is a +1, minus 2. We're just plugging all our x's and y's from the original graph into our transformations to get them redone for us here. So now we have our values. I go and I try to find my smallest denominator. So my smallest denominator is pi over is 6. I'm going to count by pi over 6s. I always count by that smallest denominator. So I'm going to count by pi over 6. So negative pi over 6, 0, 1 pi over 6, 2 pi over 6, and 3 pi over 6. There's 1. And I'm going to go down to -3. So this was negative pi over 6. This was 3 pi over 6, which is pi over 2. So we're going to go ahead and we just make sure that we label our graph. You have to label the axes to get credit on it. So negative pi over 6 and -2, that's right here. 0, -3. Pi over 6, -2. Pi over 3, or 2 pi over 6 and -1. And 2. Now I can go ahead and tell my range here real quick. So my range would be from -3 to -1. The y-intercept, very easy to tell. It's actually on my graph here. It makes it a little bit easier. So my y-intercept was 0, -3. Even, odd, or neither. Again, even means that a relative max or min is on the x-axis. Odd means that it has rotational 180-degree symmetry through the point 0, 0. Well, first of all, I didn't even pass through the point 0, 0, so odd's out. And neither if it's neither one of those. Well, I actually have a relative minimum on the y-axis, therefore this is going to be even. My relative min, so I'm finding that smallest value. In this case, that smallest value is at 0, -3. So 0, and then I'm going to add my period. So my period was 2 pi over 3. So 2 pi over 3n, because this will go forever, and -3. And then I'm going to add my relative max in. So the graph goes from increasing to decreasing. And that happens at pi over 3. Plus 2 pi over 3 n. And -1. All righty, friends, we are cruising through. So now, if we keep going through here, we get to cosine. Cosine is going to be the exact same. Nothing changes. Cosine will be the exact same. All that changes is what values we start with. So everything is the exact same as sine, except the points we start with for our transformation. So everything is the exact same. The only thing that changes is the points. Notice. Let's see if we can't graph these out here. Our points change. Instead of 0, 0, I'm at 0, 1. Instead of pi over 2, 1, I'm at pi over 2, 0. Instead of pi 0, I'm now at pi -1. Because we're using different values on the unit circle. But these would end up being my 5 major points. But nothing else is going to change. So when I'm dealing with cosine, everything is the exact same as sine, except for the starting points. Nothing else will change. So it's not like we're learning two different things. We're not. We're learning one thing. And actually, it's more of a review of what we did first semester. All we're doing is just getting two different sets of points that we start with. So we can still use transformations to graph cosine. We just get different points to start with. All right, so let's deal with cosine. And again, everything stays the same. Still have our A, our B, our C, and our D. Just get different points to start with. So friends, why don't you guys go ahead and pause the video and go ahead and take a shot at this one, and then we will come back and take a look at it. All right, let's see how you guys did. So we got to factor out that 4 there. So 1/3 times cosine. Take that 4 out. That makes this x minus pi over 4. Literally, factoring out the b value is the one thing that people tend to forget on graphing. And it can cause a lot of problems. Just make sure you get that b value out of there, -1. All right, so that means I have an a of 1/3. I have a b value of 4. I have a c value of pi over 4. And I have a d value of -1. So again, we can do everything here. So amplitude is still absolute value of A. Absolute value of 1/3 would be 1/3. Vertical reflection, in other words, is a negative. And you would tell me, nope, it's not. Period is still going to be 2 pi divided by the absolute value of B. So 2 pi divided by the absolute value of 4. So our period length is going to be pi over 2. Our phase shift is still our C value. So C was a positive pi over 4. So that means we're going to go right pi over 4. And our vertical shift is still our D value. So that means we're going to go down 1. And then we have our domain and range. And since it's sine and cosine, the domain is always still going to be all real numbers. The range I don't know about yet until we actually go through and figure it out. So here we go. So we actually can do a lot of this stuff before we even get into the problem, which is kind of cool. So instead of 0, 0, now I'm starting at 0, 1. This is cosine. Pi is 0. That's pi over 2. Sorry about that. Then I get pi, negative 1, 3 pi over 2, 0, and 2 pi and 1. So we're going to have x divided by b plus c. We have y times a plus d. So x divided by 4 plus c, so plus pi over 4. Y times a, so my a value is 1/3, so I'm going to go y times 1/3 plus d, so d was minus 1. All right, let's plug them all in. So 0 divided by 4 is 0 plus pi over 4. Pi over 2 divided by 4 is pi over 8. So pi over 4 is the same thing here as 2 pi over 8. I'm going to remember that here because it looks like I'm going to be adding by some pi over 8s here. So pi over 8 plus 2 pi over 8 would be 3 pi over 8. Pi divided by 4, pi over 4 plus pi over 4 would be 2 pi over 4. Which is pi over 2. 3 pi over 2 divided by 4 is 3 pi over 8 plus 2 pi over 8 is 5 pi over 8. Two pi divided by 4 is 2 pi over 4 plus another pi over 4 is 3 pi over 4. So we get all our x values. Now we do our y. So 1 times 1/3 is 1/3 minus 1 is negative 2/3. 0 times 1/3 is 0 minus 1 is negative 1. Negative 1 times 1/3 is negative 1/3 minus 1 is negative 4/3. And then negative 1 and negative 2/3. Let's see, that's not quite what I wanted. Make that work though for a second. There we are. All right, so we get our points. And I'm looking at my smallest denominator here. So my smallest denominator is pi over 8. So that means I'm going to count everything in terms of pi over 8. So I'm going to go back and change this to 2 pi over 8. Just so I'm have everything kind of uniform. 3 pi over 8, that's going to make this one 4 pi over 8. Just so I know that when I graph it, why I'm graphing what I'm graphing. 5 pi over 8, and that would be 6 pi over 8. So I'm going to graph by pi over 8, since that's my smallest denominator. And notice I have all these 1/3 here. So what I'm going to do then is I'm going to change that. I'm going to count by ones over here. So that'd be 1. So I can kind of find those 1/3 a little bit. You don't have to do that. I'm just going to do it because it's going to help me out here. So it makes this a -1 right here. And then I'm counting by pi over 8. And this is why it's so important that you guys scale your graph. You scale the graph so that everybody knows what you're doing here, friends. So that's counted by pi over 8. So that's pi over 8. And I went out to 6 pi over 8, which is 3 pi over 4. But scale your graph so everybody can tell how you're graphing. All right, so I got 2 pi over 8 and -2/3 that we already got here. And then I have 3 pi over 8 and -1. 4 pi over 8 and -4/3. It goes here, and then it comes up here. So we're going down, then we're going up. All righty, well, here we go. What is the y-intercept? Guess I could probably finish off the range real quick. Let's do that. The range, I went from -4/3 to -2/3. So my y-intercept, I'm plugging 0 in. So y equals 1/3 cosine of 4 times 0 minus pi minus 1. So I get y equals 1/3 cosine of -pi minus 1. So negative pi is the same thing as pi. Cosine of pi is -1. So y equals 1/3 times -1 minus 1. So that's -4/3. So there's my y-intercept. 0, -4/3. I'd have to continue the graph on to see, did I get a relative min or max on the y-axis? Well, it turns out I am going to get a relative min on the y-axis. So for my even, odd, or neither, this is going to be even, because I have a relative max or min on the y-axis. And then we get to our relative min and max. So smallest value, that'd be my relative min. And notice everything we're doing here is the exact same as sine. We just want to make sure that we just have different starting values. So that smallest value was at pi over 2. And we include our period. So our period was pi over 2 as well. So plus pi over 2n. Comma -4/3. And our relative max. so the relative max is at pi over 4. And I could have used 3 pi over 4 here too. It doesn't matter. I usually use the first one, but it doesn't matter. And negative 2/3. So again, cosine, exact same as sine. Well, friends, we're just about done here. Let's just go ahead and tie it into one quick application, and we'll call it a day. All right, so how can we use this in some sort of an application type scenario here? What are the period, amplitude, and equation for the sine wave? So the period, so I'll go ahead and take a second, read through the problem, and then give yourself a shot, and then we'll talk about it. All right, so here we go. Period length, that's basically how far it is from 0. So if I'm looking at my period length, I just go to the end, figure that out there, that's 40. So that means my period then is 40. We'll come back and play with that here in a second. Amplitude, you can see the biggest value here. You can see the smallest value here. So amplitude, that would be the largest value, so 65, minus the smallest value, negative 65, divided by 2. And since they're both 65, friends, that's just going to be 65. So the next thing they asked me to do, there were no phase shifts on here. That's pretty cool. The next thing, though, they asked me to do is they asked me to write an equation for it. So I'm going to write an equation in terms of sine. I don't have a C and a D value here because there were no phase shifts, but I'm going to go through here and plug everything into my transformation of sine. Again, even though I'm putting this C and the D, there were no C and Ds, so those won't be part of the problem here. I had my amplitude was 65, so I'll put that in. So 65 times sine of my B value. Well, let's come back here and take a look at our B value here. It's 2 pi over B. So 2 pi over B equals my period. I don't have to put in absolute values because the graph goes up the right way to begin with. So it's not going to be a negative value. So if I put this over 1 to cross multiply, I get 2 pi equals 40b. So then we can divide by 40. So 2 pi divided by 40 equals b. And if you simplify it, pi over 20 equals b. So that means my b value is pi over 20. So use the equation to estimate the change in the line of sight velocity on day 36. So on this last part, that means x is 36. So make sure your calculator is in the right mode. We're in radians, not degrees. And we're going to plug in 36 for x. So pi over 20 times 36. And when you plug that in, friends, you end up getting a value that is approximately negative 38.2060 0.415. And now we write about it. And then we call it a day. The change in the line of sight velocity on day 36 is approximately negative 38.206 meters per second. All righty, friends. Well, that takes care of our introduction to sine and cosine graphs. I'll see you guys in class tomorrow. We'll talk a little bit more about it. Take care.